So out of 8 and 13, 8 is the smallest element and already it is in its position. You need not to swap this here. The first step is we have to find out the smallest element, and the smallest element has to be interchanged with the first element of the given list or at the index 0. We are calling the function, and with the help of for loop we are going to print out the final elements or the sorted elements in a given list. Dear students, welcome to Computer Science classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, let us start our discussion with the chapter sorting. And in this session, we are going to talk about the selection sort. So this is one type of sort, a selection sort. Let us discuss about selection sort in this session. Now in the next slide, we will see what is the selection sort, definition and algorithm or the procedure. So what is selection sort? So in selection sort, the smallest element is selected from the unsorted array and swapped with the leftmost element, and that element becomes the part of sorted array. So this is the technique or a process in selection sort. So what is the first step here? In this sort, first step is we are finding out the smallest element of the list or the given list. So in that list, and here there are two concepts, or we are dividing the given list into one unsorted list and second one is sorted list. So here there are three concepts. One is we have to find out the smallest element in the given list. Next one is, and there are two parts, or we are assuming that there can be two parts in a given list. One is unsorted array and sorted list or array. So here this same process continues for the next element in the unsorted array till the list is sorted. To sort a list having n elements, the selection sort takes or makes n-1 number of passes through the list. And the list is considered to be divided into two lists. One is the left list contains the sorted elements and the right list containing the unsorted element. If there are n elements in a given list, so this selection sort takes n-1 passes or n-1 iteration to sort the given element in a given list. And as I told you in the first point here, there are two sections or there are two parts in the given list. One is the left side list is considered as the sorted elements, or where we can swap the elements and it becomes the sorted elements. And another part is the right hand side or the right hand side of the list, it is considered as unsorted elements. So here in general in selection sort, the first step is we are finding the smallest element, and the smallest element is swapped with the first position of the given list, that is on the left hand side. So during the process, so the smallest elements which keeps on adding at the left side here, and it becomes the sorted list, and the right hand side, that is another part, so it will be the elements of unsorted list. So this is the process or the algorithm for selection sort. Now let us analyze this with one simple example. Now let us consider the given list as 8, 7, 13, 1, minus 9, 4. Here there are 6 elements, so the size is 6, and this process, the loop takes n-1, that is 5 iteration or 5 passes. Let us start with the in pass 1 or in iteration 1. So here we are going to compare the two elements here, 8 and 7. So here the process is to find out the smallest element. Now here comparing these two, 8 is greater than 7. So here 7 is the smallest element. Now after 7, now you can observe this, we have marked with the 7 in a green color, it is the smallest element. Now out of 8, first we assume that in the first step 8 is the first element, that index 0, the element at index 0 is the smallest element, and that is compared with the next element. Out of 8 and 7, 7 is the smallest. So we mark this as the smallest element of the given list. Now again 7, and we are going to compare with the next element, 7 and 13. Here 7 and 13, 7 is the smallest. So in the next step, we are keeping the element 7 as the smallest element. Again we are comparing this 7 and 1. Next element is 1 here. 7 and 1 here. 1 is less than 7. 1 is the smallest element. So we are making the 1 as smallest element, not 7. So in the previous step, we have assumed that 7 is the smallest element. Now at this step, we are finding 1 is the smallest element. So we are saying that 1 is the smallest element, not the 7. Now next comparison from this 1 and the next element, that is minus 9, and minus 9 is the smallest element. So we are marking this in the different color. So assume that minus 9 is the smallest element. Now again minus 9, and next one is 4. Here minus 9 and 4. Minus 9 is the smallest element. So we are going to swap the smallest element with the first index. See, that is the process or a technique. So the first step is we are finding the smallest element of a given list in the one pass. So that smallest element has to be swapped with the first index or the first element. Here if you look at the beginning, the element is, we considered element 8 as the smallest element. At the end of one pass or one iteration, we came to know that minus 9 is the smallest element that has to be swapped with the 8 here, the first element. So once this has been swapped, interchanged, so minus 9 comes here and all other elements moving one step forward or towards right side. So 8, 7, 13, 1 and 4, because we are interchanging 1 and 4. So now if we observe this, as I told you in the beginning, here we are considering there are two parts. On left hand side is the sorted list of elements. On right hand side it is unsorted list of elements. So there are two parts in the given list. So at the end of one pass, the smallest element we could find is minus 9. So that will be placed or interchanged at the first position. Now in the next pass or in next iteration, see, we'll start with this process. At the end of pass 1, these are the elements. We'll continue with this output. In pass 2, we are going to start with the element 7. So here minus 9 is less than 8 and 8. So next one is 8. 8, I am going to compare 8 and 7. So out of 8 and 7, 7 is the smallest element. We are going to mark this 7 as the smallest element. Next again 7 and 13 we have to compare. Again out of these two, 7 is the smallest element. So again this 7 again comparing with the 1, the next element here. So out of these two, 1 is the smallest element. Now we are going to mark 1 as the smallest element and not the 7. So again 7 and 1, and in the next stage I am comparing 1 and 4. Out of these two, 1 is the smallest element. So in that case, 1 is smallest element. So this has to be interchanged with the second element, that is 8 here. So this has to be interchanged at the end of pass 2 or at the end of iteration 2. So here 1 come to this position and all other elements will be 7, 13, 8 and 4. So we have swapped these two values. 1 comes to this position, 8 goes to this place. See, this is the end of pass 2. These are the elements. If you observe this, again this is the sorted list and this is unsorted list or an unsorted part of a given list. In the next slide, we will see pass 3 or iteration 3. In this iteration, minus 1 and 9, 7, 13, 8, 4 are the elements. Now I am going to compare with minus 9 is already sorted, 1 is in sorted. So next I am going to compare 7 and 13. So 7 and 13. So out of these two, 7 is the smallest element. We have to mark 7 as the smallest element. Next one is 7 and 8 we have to compare. So 7 and 8, out of these two, 7 is the smallest element. Again, next step is 7 and 4. We have to compare the 7 and 4. Out of these two, 4 is the smallest element. So at the end of pass 3, we are going to swap these two values. So 4 comes to this position and 7 comes to its position. So at the end of pass 3, these are the elements. If you observe this, this is one part of a list. The second part of a list, this is a sorted part of a list. This is unsorted part of the given list. This is at the end of pass 3 or iteration 3. In next iteration, the pass 4 here. So here we'll start with the elements at the end of pass 3. So here -9, 1, 4, 13, 8 and 7 here. So now we are going to compare the 13 and 8 here. So this is unsorted list. So unsorted part of a given list, 13 and 8 here. 8 is smallest element. We have to mark it as 8 as the smallest element. Next one is, again the next step, we have to compare 8 and 7. 8 and 7. 7 is the smallest element. So we have to swap the elements or we have to interchange the elements. So we are interchanging this 13 and 7. So 7 comes to this position and 13 takes its position. So this is at the end of pass 4. These are the elements of the given list. Again, if you observe this, from here to here is sorted. And this is second part, unsorted part of a given list. In the next iteration or in the pass 5, let us see the elements here, -9, 1, 4, 7, 8 and 13. Here in the previous iteration or in the previous pass, we assume that 8 was the smallest element, which has been interchanged. Now we are left with the element 13. We have to compare 8 and 13. So out of 8 and 13, 8 is the smallest element and already it is in its position. You need not to swap this here. So at the end of pass 5, these are the elements. Our elements are arranged in this order. So this is the final list, or at the end of this selection sort, the elements are arranged in definite order. In this example, the elements are arranged in ascending order. So this is the selection sort. Students, let me brief you once again the same concept here. So in the selection sort, the first step is we have to find out the smallest element, and the smallest element has to be interchanged with the first element of the given list or at the index 0. And again, in this procedure, we are assuming that there are two parts in a given list. On left hand side, it is the sorted list. On right hand side, it is the unsorted part of a given list. So at the end of the process, the elements are arranged in a definite order by using selection sort. In the next slide, we will see these are a programming code, or these are programming statements. We are defining a function here. So def is a function, list2 is the input or the parameter, and this is n equal to length of a list2. We are finding the length of the given list, and here using one loop inside another loop. Here for I in range n and for j in range I plus 1, length of list2 is going up to n minus 1 iteration. And here we are comparing here, list2 of j is less than list2 of minimum. So here we are assuming that the smallest element is the given list is the first index. So in this process, at the beginning, we are assuming that the smallest element or the minimum element in the given list is at the index 0. So we are going to assume that, then we proceed further. So at the end of this function here, it is going to find out the smallest element and is going to swap with the index 1 or as the first element. The smallest element is swapped with the first element at each and every pass or iteration. Now finally, this is the given list. We are calling the function, and with the help of for loop, we are going to print out the final elements or the sorted elements in a given list. So this is we have defined the function selection sort in Python programming. Students, so far we have discussed about a selection sort, a type of sorting in Python. Let us continue our discussion in my next session. Thank you very much.